Hey, Algebra 1. Today we're going to finish up 9.2. Just to talk about, we will have a test on 5/14, May 14th. That's Wednesday of next week. So this is the last new thing. So today will be that homework. I think Thursday we have a class, and we might have Friday a class. I'm not 100% sure. But I think we're going to have at least 2 days of review, so I'll make sure to post some stuff for you guys before then. Okay, so 9.2 day 2. All right, it's been a while since we done any 9.2 stuff, so let's just remind ourselves. There's a lot of aspects to a parabola, and particularly where are the solutions of a parabola. So just a reminder, there's 3 situations how a parabola could look. Let's purposely make it a little off-center too. But you could have a parabola that has 2 solutions. This is where it hits the x-axis, and this is where it hits the x-axis. You have a parabola with 1 solution, and that 1 solution is where it hits right here, okay? And it only hits it exactly at 1 place, okay? Usually in that situation, there's, well, yeah, it just exactly hits at 1 place. And then you have another solution where it never hits the x-axis. So either above it, or if it was upside down, below it. Okay. So we have 3 types of solution sets here. So today's lesson is how do we get a graph in order to get said solutions. So what's nice about 9.3, I think this was 9.3, my fault. 9.3 is that what we're going to do is still do the same thing we were doing for graphing, but we're looking for something particular, okay? So let's do the same thing we were doing for graphing. So let me think of one real quick. All right, do the editing, I just drew it. Y equals x squared plus 6x plus 5. So we're going to use our method for 9.2 graphing, and we're going to see what happens, okay? So y equals x squared plus 6x plus 5. What we're going to do there is we're going to graph our thing. So let's start identifying our ABC. So that's 1, 6, 5. Part 2, we need to find the x of the vertex. So to find the x of the vertex, we need negative b over 2a. Okay? This should be a minus 5. Let's fix that real quick. No, wait. No, plus 5 is right. Okay, yeah. So, I'm sorry. So it's going to be negative 6 over 2 times 1. So negative 6 over 2 is negative 3. Okay? That's the x of the vertex, all right? All right, so what are we going to do with that x of the vertex? Well, we're going to take it and plug it into this equation right here. So that is negative 3 squared plus 6 times negative 3. 6 times negative 3. And a plus or 5, okay? So negative 3 squared happens to be a positive 9 minus 18 plus 5. Negative 3 times 5 is negative 18. Negative 9 plus 5. We get negative 4 equals y. So your dy and your x and y is negative 3, negative 4. Okay? So let's make a table. Now, this is how I'm going to make the table. And this is why it's slightly different when I'm asking for a solution. First, I'm just going to make the middle of my table. Kind of like empty like that. So I know it's negative 3, negative 4. And let's go negative 2. And, I'm sorry, wrong way. This is smaller, right? So this is negative 4 and this is negative 2. I guess I'm still making the same table. I don't know why I said it like that. Negative 1 and negative 5, okay? I'm just not going to put the xy's, and there's going to be a reason for that. And this one it won't show, but I'll show in the next reason. All right, so let's plug it in. So we just found this. We also know that parabolas are symmetrical. So if they're symmetrical, that means if this one is equal to, let's say, 1,000,000,000, this should also equal to 1,000,000,000. So I'm going to use the smaller number here, which looks like -2. I should say the smaller numeral, or smaller absolute value. So -2 squared plus 6 times -2 plus 5. So that's 4 minus 12 minus 12 plus 5, -8 plus 5, -3. So if this one's -3, then this one's also -3. Let's plug in -1 now. -1 squared plus 6 times -1 plus 5. There's a positive 1, minus 6 plus 5. You do the math, that should be 0. 0, 0. Okay, and now I'm going to put my x and y's, and here's the reason why. When you graph this, and when you make that table, and when you do that, remember from, oh, I didn't put it on the back, that I said that the solution is where it hits the x-axis. So tell me, where in the y values does it hit the x-axis? What is the y value when it hits the x-axis? Well, it's when y equals 0. So it's when y equals 0. So out of this table, what are my two x's that y equals 0? My two x's where it gives me y equals 0 is here at -5 and here at -1. So my answer for this question is, if I ask you, give me the solutions or the roots to this equation by graphing. After all this, you just look for, and this is the only thing you look for, is where does y equals 0 on this graph, okay? Where does y equals 0 on this graph? And in this question, y equals 0 on this graph at -5 and -1. And those are your solution, okay? I'm about to do another one. This one, I'll purposely make a one solution. Okay, so editing, we're next to on the next one already. X squared plus 4x. Notice there's no plus c. That's a big hint that something's up. Okay, so why don't we find what our solution is? Again, we're looking for where y equals 0 on the graph or on the table. Now, I could recommend you like graph your shape and maybe I should have mentioned on the last one, you could graph your shape first, and then you could kind of see from that picture if you're going to have a 2 solution, 1 solution, or 0 solution. So actually physically graphing it will give you a nice help in seeing where the answer is. Okay, so we got x squared plus 4x. So let's identify our ABCs. I'm going to follow the same exact steps as always. So that's a 1, that's a 4, and that's a 0. I don't see a C. A C does not exist at all, so it's a 0. All right, so let's find our x of the vertex, so -b over 2a. That's -4 over 2 times 1. That happens to be -2. It's the x of the vertex. Oh, I made a mistake. This doesn't cause what I wanted to cause. Let me fix this. Actually, let me just finish it just to show what the solutions are. But I wanted to have one solution. This is not a one solution situation. But let's just go through it anyway. So that's x. I'm going to go a little faster though. So -2 equals x. So then we plug it in. -2 squared plus 4 times -2. So that's 4 plus or minus 8. So that's -4 is your y. Okay, so you got -2 equals x, -4 equals y. So your middle of your table is going to be -2, -4. The reason I'm kind of making the middle first and then spreading out is sometimes I don't know how far I'm going to have to go to find a solution. I mean, I kind of know, but sometimes you don't know. So why don't we do -3 and -1 first? So we're going to test that out. We'll just do one set. And if that's enough, then we stop. If it's not enough, then we keep going. So I'm going to plug in -1. Looks like it's easier out of the two. So -1 squared plus 4 times negative 1. That's going to all end up being negative 3. So that's a negative 3. So let's go to the next one. Negative 4 and 0. And this one, again, is also symmetrical. Oh, this is negative 3. So this is also symmetrical. So 0 over here. We're going to plug in 0, but that's really easy. It's 0 plus 4 times 0. That equals 0. So these are your solutions. At this point, you can stop, and you know your solutions are at x equals negative 4, at x equals negative 4, and at 0. Okay? So that's your final solution right there. That's your solutions to the graph, they say. Or the roots to the graph. Okay, so sorry for that. That was not an example I wanted to show, but it still works. Let's do an example where there actually is only 1, 0. All right, 99% sure that this one's going to cause a one solution. Actually, I know for a fact it does. Okay, so let's do our normal thing. We're going to start graphing A, B, C. So A is 4, B is 24, and C is 36. So we do our negative B over 2A. So that's negative 24 over 2 times 4. That's negative 24 over 8, which is negative 3. So negative 3 is my x. So I take that and then I plug it back here. So 4 times negative 3 squared plus 24 negative 3 plus 36. Now I'm getting a little nervous. I hope this actually does go to 0. This is 9. 9 times 4 is 9. 9, 18, 36. Minus 24 times 3. 24, 48, 50, 60, 72. Okay, it works out. Plus 36. So 36 minus 72 is negative 36 plus 36, which equals y 0. So y equals 0. So you can start your table, but I just want you to see something. So this is negative 3 and this is 0. Remember, where's my solution supposed to be? Oh, my solution is where the y equals 0. So I look at this and I say, wait a second. The y equals 0 is at the vertex. And if you were to keep going, and this would be 4 and 4. The other one I believe would be 20 and 20. Like if you kept going, you should notice that we'll never go back to 0 at any chance. We'll never go back to 0. So here, the vertex is the solution. So if your vertex is your solution, you know automatically that's a one solution situation. Okay? And now I'm going to make one that's purposely a no solution. And we're going to see how that looks. And how you could tell that before you do like infinite amount of problems. Or infinite amount of like table. Okay, let's go to our last one. X squared plus 2x plus 5. I dropped my eraser, so that's all. All right, so we do our same thing. A, B, C. 1, 2, 5. Okay, so negative B over 2A is negative 2 over 2 times A, just 1. And that's going to be a negative 1 for your x. All right, so we plug in a negative 1. That's negative 1 squared is 1 minus 2 plus 5. You end up getting a, I'm being really slow, 4. Okay, equals your y. All right, so let's work with that information. And I'm sorry, this one I'm going fast because we already did like 3 of these. So negative 1 over 4 is our middle. So let's go out a little bit. So let's go 0 and negative 2 and see how that looks. Okay, so I'm going to plug in 0 to the equation. That's a lot easier. Well, 0, this would disappear, and this would disappear, so you're left with 5. That's really easy to find. So that's 5, and that's 5. Why don't I plug in a 1 also? This is negative 3, my bad. Okay, so let's plug in a 1. 1 squared is 1, plus 2 times 1 is 2, plus 5. So 1 plus 2 plus 5, that's 8. All right. So let's carefully look at this. Now, you're like, well, Mr. Tobel, I didn't get to 0, so do I keep going? This is why the visual aspect is actually a bit important. So try to think about it as you graph it along the way. And maybe there is a value of graphing it as you get the points. So you got negative 1, 4. That was your first point, okay? Negative 1, comma 4 was the first point we found. That was the vertex. The next point we found was 0, 5, and negative 2, 5. So it looks like this, and it looks like this. And then the next point is 1, 8, which is up here, and then the other one's over here. So when you graph this, and you visually look at it, and this is kind of why they use graphing sometimes, when you visually look at this, you could tell, oh, wait a second, this will never hit the x-axis. At that point, when you tell, oh wait, it'll never hit the x-axis, you could stop right there and say it's a no solution. Now, depending on who you are, you might find it really quickly. You might have done 100 of these. I hope you didn't have done 100 of these. So at least I need this much information on boxing right now. At least I need you to show me that you notice that it's going up and it'll never go back down to 0. Or if it was upside down, it's like at, let's say it was a negative 4 and it went to negative 5, it's going more down and it'll never get to 0. So you have to at least show me 3 units in this one, okay? And I guess I didn't really talk about how I want you to show your answers. I want you to make your table, start it at the vertex, and then go one step at a time. So go out one, like out one, and then out another, and then out another. The reason I want you to do it like that is because because we're looking for the solution, let's be optimal and find us. And as soon as we find the solution, we end our, we find it, and then we're just happy and we're done. Okay. The homework's going to be the same worksheet, and I'll have a Zoom for today. Okay. Have a wonderful day, guys.